Our next presentation is going to be from Mr. Bhumik Patel and Kevin Kovac. I think you'll be blown away.
Hello everybody, my name is Kevin Kovac. I attend Lake Park High School.
I'm Bhumik Patel. I also attend Lake Park High School.
Okay, before we start, I'd like to talk about this last horrendous winter we just went through. How many of you guys had to pull back out your shovels in April? Yeah. So hopefully ours will help solve some of those problems. Our invention was a heated landscape blower. The problem that we set out to solve was to create a new solution for the removal of snow and primarily ice. 50% of Americans experience freezing temperatures. And for our solution, we really wanted it to make it economical, ergonomical, and environmentally friendly.
So some of the solutions that are already out there, like shovels, snow blowers, de-icing salt, and ice torches, don't really do the full spectrum of the job. Shovels and snow blowers only really go after the snow, and while the de-icing salt and the ice torch only really go after the ice. And they really don't do the job, as the ice torch is quite dangerous because it's an open flame, and the de-icing salt can actually hurt pavement or damage pavement and can hurt the grass, damaging the environment.
We asked several survey questions, and our first one was whether or not you were a homeowner or not, because if you're a homeowner, you normally have to be removing you have to shovel your own driveway and your own sidewalks. So that was the main purpose of the first question.
This just shows like how what tools that people actually generally have, and most people had like snow removal tools, and not as many people had ice removal tools.
Third question we asked was whether or not they received snow or ice on their driveway or sidewalks, and whether or not, and how many people actually had to personally go out and shovel and remove the ice. And as you can see, almost everybody except for a few had to personally remove the snow and ice.
So when asking like if someone actually had to remove the snow or ice, we had to ask if they had any difficulty with it. Because if there was difficulty, that means there's more of a reason for something to help them remove it. And so 81% are saying they would like something that could possibly help them.
Another question we asked was whether or not somebody has slipped on the ice, because if you slip, you can cause injury to yourself, and you obviously don't want to get injured. So hopefully our invention will help solve that.
So we had to ask how many people were actually willing to buy a product that was affordable and could still do the same amount of work if it was still as easy or easier to remove the snow and ice. And so we had to go through like a decision process of how we wanted to go through it, because we know we wanted to use a leaf blower because we knew it had the high air power to be able to move like water around once it had melted. But we had to also see how would we actually heat up the air so it could melt the snow and ice. So the couple of things we had to do was the different ways we were actually going to wire some heating element. And so we were either going to wire the heating element through the tube as a coil all the way through on the inside, or we're going to do a diagonal pattern as we did now.
For our solution, it's easy to use, affordable, and safe. Since there is no open flame, there's no there's no burning of yourself because of it's all concealed inside the nozzle. This is an inventor part that we created on a CAD program that is primarily it's pretty obvious, you can see, it's primarily used to hide or to cover the wire, cover external wires from being damaged or being a possible electrocution of somebody if the water gets onto it.
And so the heating element we chose was nicromium 60 wire, and this heating element is very common. It's used in toasters and electric ovens and in hair dryers. And so since it is so common, we knew that it had the potential of getting warm enough that we would be able to use it to be able to heat the air in order to melt snow and particularly ice. And the reason we chose this coiled style of a wire is because we can have more of the wire in a smaller space compared to a single wire, which we may be able to use less of, but then would be less effective overall. The blower we used was a Toro power sweep, and this blower is rated at 7 amps, and the lowest setting on the motor runs at 100 miles per hour, and the highest setting is 150 miles per hour. So we definitely have the airspeed to be able to move the water away once it has melted from the snow and ice.
This is one piece of our mounting system. We decided to use an eye bolt with a ceramic thermocoupling inside and held together with silicone adhesive. You can see right now they stick out. They're pretty obvious right now. And it's to hold the wire in place so it's just not just all jammed in there. It's so that we can diagonally wire it throughout the nozzle.
And so this is pretty much like a simple circuit of what's actually inside the motor. It's just a motor and the resistor, which is the heating element, that's in parallel with the AC power source. So we had gone through like 2 stages of testing. First we had to test whether the nichrome wire would actually heat up to how much we wanted to when plugged directly into an AC power source. So this is pretty much, we have 6 of our mounts on a 2x4 with the wire running, with the nichrome wire running through it, and it's just crimped onto an AC power source. And the second testing we did was to actually see if this product would work. And to see if this would actually work, we had to melt ice, because that was our main purpose of this, was to melt it. And so with our control group and the heated group, you can see that the rate, which was in like the amount of ice in kilograms per hour at the given temperature, could be up to 3 times higher, depending on what the temperature is and how long it's been exposed to the heat.
For cost, the blower is the majority of the cost. It may look like the sealant is a lot of money, but we only used a very small portion of the sealant, so we'd be able to use 1 tube for multiple blowers. And the eye bolt, we have 6 per blower, and that's roughly $1.25. The ceramic thermocoupling, $1.75 for 1.5 inches. 12 gauge or 16 gauge wire, 3 feet is used, 60 cents. Iron washers, nichrome 60 coiled water, wire 2 feet for $2.96, and it all comes under $50 at $48.48.
And so you can see that this actually does work. And even though it may take a long time for it to actually heat up, it still actually works.
If we could change something or redesign it, we would definitely be adding a bigger nozzle onto the end of it, because we weren't able to fit as much wire into it as we intended, and it would roughly double the wire and be doubling the time and shortening the time of how long it would take, so it would be way more effective.
We also wanted to redesign it so we could have a removable nozzle, so that if in the winter you could swap out with this heated one in the fall or in the spring with a normal one, where if you just want to move around the leaves, even though you could still use the removable one, or the heated one in the fall or spring. So we'd like to thank Andy Hedgeland from Bison Gear and Engineering, Matthew J. Van Meter from Hendrickson, and Mike Rabinsky from COD and Fermilab. Does the panel have any questions?
So, why is this a better alternative than using salt?
The thing with salt is that other than it takes a very, very long time for it to actually go ahead and break up pieces of ice, it doesn't actually remove the ice completely, even though you may put it down. It can actually end up being in chunks, and over a long period of time it could melt because it's becoming a a solution that freezes at lower temperature. And also the salt can damage grass and pavements as it can stay there and eventually erode concrete.
So were you able to test it since we had such a harsh winter?
Well, we obviously weren't able to test in the winter because this is a spring project, but we were able to successfully test it on blocks of ice where we saw the rate was a lot higher with the blower itself than compared to the control group that's sitting next, that was nearby the block, still in the sun. Both testings happening on different days in the sun.
So you just used one block and
We had two separate blocks. One was left as a controlled outside. The other one had the blower running at it, and it melted at a much faster rate than just leaving it by itself in the controlled.
now, and how much more power is this since you have a heat element in here? How much more power are you using?
Since the motor is right at 7 amps, the amount of wiring used is only about 0.5 amps, so it is safe to use in a home when most areas in the house are rated at 15 amps. So it should be safe to use when you're using it, especially outdoors, because the outdoors is usually separated from the remainder of the house.
And how did you deal with the safety issue since you have a coil wire in here?
Well, the whole purpose is that we were able to conceal most of the wire within it. And in order to actually put in, we actually had to cut the tube to put in, otherwise we'd have to completely build our own. And since it is, since the air is moving so quickly, the air is still the heat is being lost as it's being, leaving the tube. And so the heat, like the danger of being burned is a lot lower than if you were to just, stick your hand onto the coils itself while it's warm. And that's the whole purpose of this being sealed. But since this is like a very first prototype, this is the only thing we could do. Other safety issues is electrocution, which is why we had this part made so we could hide some of the wiring to make sure it wouldn't get exposed and cause electrocution.
And on our mounting system on the eye bolts, they have a thermocoupling in it, so it is a resistance so the heat doesn't travel from the wire into the bolt and having it just melting the plastic.
And what's the temperature when it comes out of the nozzle?
It varies depending on what the outside temperature is, because since the intake is still from what's the outside temperature and then gets heated here, it varies based on what is the outside temperature. And we're generally right now with the amount that's in here, the 2 feet of nichrome wire, we're seeing about a difference of 2 to 3 degrees in Celsius, which would obviously be increased with a larger amount of the wiring being more compacted next to each other.
Thank you.
Okay, you already answered one of my questions. You talked about how you actually wanted the nozzle to be longer or bigger. Exactly how long? You want it 3 times longer, 4 times longer?
Well, that would primarily come from testing and whether or not how much exact wire we would like to use and need for it to be able to melt the ice effectively. So we'd need a little bit more time for really testing and really more thought about it.
Okay. And would you market something like this with rubber bands attached to them?
Absolutely not. Because of in our time, we weren't able to seal it back up. And this is only a prototype. It's just so it's not really a final product. We would definitely have it sealed so that we have more airflow and more consistent airflow.
What would you use to seal them?
Well, since we want to actually redesign the nozzle would be actually a lot wider as well as being possibly slightly longer. And because it's wider, we would have an easier time putting these mountings in. Because it's so narrow from the front, you can barely be able to put it in without having to actually, for us, having to cut it open, pry it open, and then insert the bolts.
Okay, so you're still going to stick with the nuts and bolts, basically? You're not going to weld or glue anything?
Well, the problem with the wiring is that since it is being directly exposed, we need to have something that's able to hold it together. Because in most hair dryers, actually the way that's held together is just small, little, teeny tiny holes that are within the actual forming of the plastic. and that's where they're all held together. And here, this is sort of our temporary form in order to keep it away from the plastic, because our worry is that if the wire was direct contact with the plastic, it would actually begin to melt.
Any other questions? Audience?
Audience, anybody? Yep.
How close, with having the shorter nozzle, how close do you have to be to the surface? Because body mechanics wise, you'll be stooping over if you have to, if you're going along the sidewalk.
I mean, because it's actually, this is pretty much, we just took a normal blower and we were using it as, when we just modified it. Still, if you're holding it at a normal length in which you would be using it, at this length is where we did our testing. And holding in this length is what we got our results from. So even at a normal usage rate, it would still be quite effective.
How quickly does it heat up? You had made a comment about it
It
not as quickly as you would like.
When we were doing the testing on the wire itself, it took about 2 minutes for it to completely heat up, and that would also, we'd be able to change with the way we would do our circuitry, maybe a preliminary switch before you actually turn on the blower, so that the coils would heat up before the motor would be turned on.
And we wanted to add more our wire so it would get hotter, not so it would heat up faster. So it would be producing a lot more hot air out of the nozzle. Anybody else? Thanks a lot.
Well done, gentlemen.